All right, let's get right into it. Today, we're tackling something that is absolutely fundamental in MLOps, how we manage all those model configurations and hyperparameters. Honestly, getting this right is the secret key to building models that are not just high-performing but also super reliable.
So, let's just start with a question that I know every single one of us has asked at some point. You know the feeling, right? You're tweaking a model, you finally get an amazing result, and then that little bit of panic sets in. Wait, what exactly were the settings that got me here? And how on earth do I make sure I don't lose this? That right there, that's the core problem we're going to solve today.
Because let's be real for a second. The manual way of doing things, it's just painful. It is a one-way ticket to chaos. You know what I'm talking about. Dozens of confusing notebooks, you can't for the life of you reproduce that awesome result you got last week, and you're left with models that, deep down, you just can't trust. It's a super frustrating cycle. But the good news is, there's a way better way to do this.
And all that chaos, well, it leads us right into what I like to call the hyperparameter trap. And this isn't just about being a little messy. No, a lack of structure is something that actively hurts your model's performance. It damages your project's chances of succeeding in the long run.
And look at this. You can see the direct line from problem to consequence. You're tuning things by hand? Well, good luck trying to reproduce that later. You've got no real tracking system? Poof, your best results just vanish into thin air. But the one that really gets me, the absolute worst, is when you accidentally overwrite a config. Just like that, your best model could be gone, forever. That's why this lack of structure is so incredibly dangerous.
So here's the bottom line. Real professional ML systems, they're built on structure, not on guesswork. It's time to stop just hoping we remember the right settings and start building a system that actually guarantees it.
Okay, so that brings us to the core of the solution here. It's about adopting what we call the configuration mindset, and it all boils down to one fundamental shift in how you work. You have to separate your parameters from your code. Seriously, this is how the pros do it.
And the difference is just night and day. Look at this. The old way, hard-coding everything right in your script, it's just so brittle and inflexible. It is a total nightmare to track changes. But the pro way? We use simple config files. This makes your whole project flexible, reusable, and, this is huge, it lets you version control your experiments using tools you already know, like Git.
Let's make this super concrete. Here's a perfect example. A params.yaml file. I mean, just look at how clean and organized this is. All your important stuff, model parameters, training settings, data paths, it's all neatly structured in one easy-to-read place. This file, this becomes the single source of truth for any given experiment.
And you might be looking at that and thinking, okay, that looks nice, but is it a pain to actually use? And the answer is no, not at all. It's incredibly simple. All you do is have your Python script load this file. It's like 3 lines of code, and then it just runs the training process. Now, you can change hundreds of parameters just by editing this simple text file without ever touching your core logic. That separation is just so powerful.
All right, so now that we've got our configurations managed, this is where things get really cool. This is where we can unlock a whole new level of power by bringing in the right ML ops tools for tracking and even automatic optimization.
And a huge piece of this toolkit is a tool called MLflow. It's an open-source platform that was built to solve this exact problem. What it does is help you manage the entire ML lifecycle by automatically logging your parameters, your metrics, and your results for every single run. No more lost experiments.
And you know what? Getting started is way simpler than you might think. It really just comes down to these 3 core steps in your code. First, you start a run. Then, you tell MLflow to log all the parameters from your config file. And finally, you log whatever metrics you care about, like accuracy or loss. That's it. MLflow takes care of all the heavy lifting behind the scenes.
So now that everything is structured and trackable, you can put the machine to work for you to find the best hyperparameters. You can use anything from a simple grid search if you have a small data set, all the way up to really advanced methods like Bayesian optimization when you need to squeeze out every last bit of performance. These tools can just automatically run experiment after experiment to find the absolute best settings for your model.
And this code just nails it, doesn't it? Hyperparameters decide performance, managing them decides success. You see, the specific numbers you pick will define how well your model performs for sure. But it's the system you have for managing them that will decide whether your entire project succeeds or fails.
Okay, so let's put all these pieces together. Let's take a look at the blueprint for what a professional, truly reproducible MLOps pipeline actually looks like.
And here it is.
This is basically the blueprint for a clean project. Notice how there's a separate config folder. Your code and your logic live in one place, and your configurations and parameters live in another. This principle of separation is everything. It's what makes your project scalable, easy to maintain, and simple for anyone else on your team to jump in and understand.
All right, let's wrap this up with a quick recap of the best practices. This is your checklist for success. 1. Use config files like YAML or JSON. 2. Never, and I mean never, hard code your hyperparameters. 3. Use tools like MLflow or weights and biases to log your parameters. And 4. This is a big one. Track your Git commits with your parameters. That way you have a complete, rock-solid history of every single experiment you've ever run.
I want to leave you with this one final thought, and it's so important. What cannot be tracked cannot be trusted in ML. Think about that. If you can't track a parameter, or a dataset version, or a result, you just can't trust it, period. Building this system of tracking isn't just about being organized. It's about building a foundation of trust. Trust in your models and trust in your results.